Newton's cradle, or, as someone said recently, Newton's balls. What does this have to do with physics? Well, one of the interesting things about this is that these balls pop out the end very quickly. And I hope to explain why I think this is kind of like a fundamental thing of life. Kind of like a fundamental thing that's going on in life related to this Newton's cradle principle of something coming in one side and shooting out the other side seemingly right away. So my name is Floyd Maxwell, and this is Spring-And-Loop Theory is what I've called this. You're not seeing me because I don't want you to be distracted by, a person, physical appearance. I'm trying to present a new theory of physics. This is my blackboard, and I need to be able to use my hands and to show you some of the ways in which this theory works, because I'm just not a computer graphics guy, and I haven't got some slick computer models to wow you with. So for all the cynics, let's call this a very boring, very amateurish video on physics. Let's call it that, and let's accept that, and then let's move on. So why is this video being made? Isn't physics perfect? Isn't it all worked out? Well, it's actually amazing how much of physics is not worked out. I always think of gravity itself because imagine there are four fundamental forces. One of them is gravity, and we don't know what gravity is. We know the effect of it. We know how to measure the effect. We know places where there's high gravity or heavy gravity, like a black hole. We know places where there's less gravity or no gravity. If you get into empty space, then it has no gravity. But we don't know how the whole thing works. The biggest thing for me about gravity, the biggest puzzle that I had was virtually every force in life is repulsive. Think of it like a conflict. Like all movies seem to have a conflict. A conflict is a collision, an explosion, an outward flow of energy from this person and a flow from this person, and then they collide. That's the average force, typical force. Gravity says, come here. Come here. And gravity wants to attract something. Gravity can attract something in empty space. How on earth can it do that? And then, of course, modern explanation of physics says, well, space is warped and, what do they call it? Warped and bent, warped and curved, is what they say, by gravity. Well, warping is not exactly a scientific term. In fact, I'm frankly amazed they use it. Curved, okay, that's getting more scientific. The problem is the way they show it is it sort of, especially when you say warped, it sort of implies that gravity can make things all kind of like wavy. Like when you go to the circus or the amusement park and they have that mirror and you stand in the mirror and your whole body looks all wavy. Well, I don't think gravity does that. I think that gravity contracts space, locally compresses space. And when I say locally, I mean at an extremely small scale. And the effect that has on the space around it is what we call gravity. So that's kind of like the base premise of my whole theory is based around a reconception, a new conception of gravity. Trying to say what is gravity, this is what gravity is, and then what are the effects of that. So one of the challenges with my theory is I don't know where to start. To me, there are so many problems in physics. It's almost no matter where you turn, there are problems in physics. Today, this morning, I was on Wikipedia, and I counted there's a page on Wikipedia which says, what are the big problems in physics? And I counted no less than 148 questions on that page. 148 questions related to the biggest problems in physics. That really surprised me. Honestly, that really surprised me. I was thinking there would be a top 10, 5 to 10 to 15 different things. I started writing down, and I could think of half a dozen. there's really no end to problems. And to me, it clearly shows that there needs to be a breakthrough in physics. There needs to be a reimagining of how physical systems work at a fundamental level, not the surface level. We got pretty well nailed. That's how we can make this beautiful surface here, this wood countertop. We got all the physics nailed on it. We know about gluing, we know about leveling it, and planing it, and growing the trees, and harvesting the trees, and internal combustion engines, and all that stuff. We're great on that stuff. But when you get down below what we think of as the normal sort of bottom level of atoms and quarks and whatnot, we know almost nothing. Atoms, quarks seem to be a pretty small scale of things, but you can go down another, 10 orders of magnitude. You can go, or maybe it's even more. I forget the exact number, but you can go many factors smaller than an atom before you get to the sort of the indivisible point, what they call the Planck scale. And that's considered currently to be the sort of the real limit. The real smallest thing is the Planck scale, the Planck size, the Planck length, the Planck mass, Planck time. Those are the real smallest gradations, real smallest measurements. So between our everyday life and our atomic life and the Planck scale, we're actually missing a whole chunk of physics. We really have virtually no clue, except we've got all little tidbits. It's like someone took a sheet of paper with all this subatomic scale physics on it, and they shredded it, and then they've been letting us get the odd bit of confetti and look at and examine the odd bit of confetti, like virtual particles. Or we have quantum mechanics, which says that when you try and compress an electron into a smaller and smaller space, it will break out of that space. And we're like, wow, that's cool. Imagine that. I wonder how do you explain that? Or when you take photons and fire them through two slits, and you fire the photons, one photon every 10 seconds, they will still make it a diffraction pattern, a constructive and destructive interference pattern on the other side of the slit. In other words, they'll make a pattern that you normally only associate with waves, like waves on the beach, waves interacting with each other and canceling each other and making each other bigger. So how do we get these waves when we're sending one photon, one unit every 10 seconds? How is 1 unit every 10 seconds equal to a wave, which is continuous, right? A wave is made of water, trillions and trillions of particles of water all working together. How can one be the other? And so we've got these crumbs of knowledge here in this subatomic world, and also in the really big world, the macroscopic world, the world much bigger than life on Earth as we think of it, the world of the sun, and even bigger things, the galaxy, and even more massive things like supermassive black holes and all that. Well, it turns out when we get to that end of the physics scale, things break down too. So we kind of have a comfort zone. And in our comfort zone, things are very well nailed down. And then outside of our comfort zone, frankly, it's kind of embarrassing. Almost no matter what theory you want to side with, you want to side with relativity, you'll run into quantum mechanics will throw you a curve. You want to go, well, it's all a quantum world. Well, then what about relativity? Relativity is right, quantum mechanics is right, but the two don't work together. Now what? String theory comes in and tries to sort of be an answer, and I think what string theory did well was it was of the subatomic. It said, there's a subatomic world, let's get into it. So it was like a good initial premise. I think string theory, the notion of, the idea of calling them strings, was flawed. Saying that these amorphous strings, and they always just show them sort of this little flexing, like a little worm flexing, I think that idea as a way to sort of convey the theory was terrible. It doesn't match with what we know. and it doesn't allow for a lot of things. It doesn't match the energy. We're saying the energy of these springs is gargantuan. So gargantuan, it's almost incomprehensible. Like a billion times more energy than other energies like protons and neutrons and things like that. Like these springs are ultra massive, ultra powerful, and yet we're portraying them as these wishy-washy little worms, these springs. So I think that was a mistake, hence in my theory I call them springs rather than strings. The other thing was that string theory was worried about the math, and when they tried to come up with a theory that explained everything including gravity, the theory, they get divide by zeros and they get infinities and they get infinite probabilities. And probabilities should only be, what are the chances of something happen? 0 at one end, 100% likely at the other end. That should be your range, 0 to 100%. String theory was getting infinities, infinite probabilities, and didn't like that, and had some revolutionary leaps which involved multiple dimensions, more than the 3 space one-time dimensions, more than 3 plus 1 as they call it, and saying there are 10 and even 11 dimensions. And then leading to membranes, or M-branes, the M space, Calabi-Yau shapes, and a great deal of complexity. Awesome for the math guys, all the complexity, and horrible for trying to visualize the world. In my opinion, horrible. And so string theory has basically created more questions than answers in my mind. And it's gone through some revolutions. There's been some breakthroughs, relative breakthroughs, and so it's still somewhat alive. Some people are very convinced of it. I think it's, very future-looking, and we just haven't figured it all out yet. And that's kind of a convenient way to describe it, so that who's to say, right? But I think it's at a bit of a dead end. And I think that's why I sort of went back to the beginning of it in the coining the name Spring-And-LoopTheory. I was basically saying they're not strings, that's not descriptive, let's call them springs. And I've introduced something else, the loop. Using the simplest example I can think of, those building blocks that kids play with that I don't want to say the commercial word for. Well, those commercial building blocks, they have a positive and a negative part to them. One part interlocks with another part. And I think you need both those parts. I think it's ridiculous to say, we got these amorphous worms, everything is amorphous worms, and that's how you get this world, and this solid table is all through amorphous worms. I think that's ridiculous, and I cannot believe that was ever proposed. What I say is, you have this table from building blocks. You have everything from building blocks. And it's really sort of the size of the blocks determines the size of things. And those blocks can make bigger blocks, and those bigger blocks can make even bigger blocks. For example, we have some small blocks that make atoms. We have atoms that make molecules. We have molecules that make cellulose, which is a long chain, million atom, typically length fiber. And when you have a whole bunch of these million atom fibers, you get what wood is made of. And when you have a whole bunch of these wooden fibers, you get this tabletop. So this tabletop, from atoms to this tabletop, is easy to imagine with building blocks. Things that join to other things. So springs need to join to something else. And at the time that I've been researching this in the last year and a half, this is 2012, 2013, it's sort of just generally becoming accepted that gravitons, these mysterious gravitons, are loops. I don't really know what forgotten what the origin of that concept was, who came up with it, and what's the basis of it, but it makes a lot of sense to me. So let's go with it for a moment. The gravitons are loops, and there's something else which is springs. And so now we have a loop-spring system. We have a building block system. If you think about it, look at a chain link fence. A chain link fence is interlocking segments. What we could think of as loops and springs. Now technically, a chain link fence is one piece of metal going this way and another piece going this way, and then you have interlocking pieces going the other way. And so It's well, actually, I think I got that wrong. It's a piece of metal this way, and another interlocks with it here, and then another interlocked here, and it's purely interlocking vertical pieces, and you can build up this entire fence. But still, at the granular scale of it, if you just sampled a part of the fence, you could say that basically that fence is one thing looping into another thing, a loop and fastener kind of an approach. So that's the core essence of my theory.